In this video, we're going to talk about arithmetic sequences. An arithmetic sequence is a type of sequence where there is a fixed amount that is being added to each successive term. So it's all about addition, arithmetic addition. So it's a linear type function. So for example, here in this graph, every time I'm going to go up 3 over 1, up 3 over 1. So it's like I'm adding the same amount each time. So it is a linear kind of sequence. So what we call the number that it increases or decreases by each time is called the common difference, which we abbreviate with a small or lowercase d. And if I wanted to write the recursive formula for that, it's very simple. We say that it is a base n equals a base n minus 1 plus that difference. So let's put this to work. Let's try to find the 41st term of this sequence here. Now, it doesn't explicitly tell me that it's arithmetic, but I can check to see if there's a common difference here. So between 2 and 6, that's 4. 6 and 10, that's also 4. If this happens at least 3 different times, I know I have a pattern here. So that means that my common difference, or D, is going to be 4. So what I now need to know is this formula to find any term of an arithmetic sequence. So I start with a base n is going to equal that first term, so a base 1, so I need to know the first term, which I have here, which is 2, plus n, which is the number of terms that we have, minus 1, all times that common difference. So let's put it to use. A base n, so n is my 41st term, so that's going to give me a base 41. Now that a base 1 is my first term, plus now n is the 41st, minus 1, all times my common difference here. So I work that out algebraically to be 162. So let's take a look at this example. I'm going to be asked to write the recursive formula for an arithmetic sequence whose 8th term is 75 and whose 20th term is 39. Now, looking at this, I don't know what the common difference is, I don't have a list of numbers, and I don't know what the first term is. So I'm going to have to do a little bit of algebra to figure out the information that I need. So I'm going to recall the equation for any term, right, or the nth term, and that is this guy. And I'm going to plug in the information that I have. So here I know that my 8th term is 75. And I can work that out to be this equation here, which is 75 equals that first term plus 7 times the common difference. So I'm going to do the same thing with the 20th term over here. So I now have these two equations, and what I'm going to do is I'm going to subtract this one from this. Let's see what happens. So now I have my common difference, and that's going to be negative 3. So I'm going to plug that back into either one of these equations, it doesn't matter, to find my first term. So when I work that all out, whether I plug it in here or here, I get my first term to be 96, which makes sense because the common difference is negative 3, so that means I'm going to subtract 3 each time. Hence why the 8th term and the 20th term are all decreasing as we get further along in the sequence. So remember I was asked to write the recursive formula for this. So if I recall the formula for that, that's a base n equals a base n minus 1 plus d. So really the way I would express this, keeping my n's in there, so this is the recursive. Now something else I can actually write is the formula for the nth term. So let's do that quickly. So recall this basic equation. I'm going to plug in my a1 and my common difference to boil that down to a nice nth term equation. So when I work that out algebraically, I get this nth term equation right here. So I would plug in whatever value it is that I'm looking for n. So let's say I wanted to find the 79th term. I would plug in 79 right here into n, and that would give me the 79th term, which is a nice simple way instead of plugging it back in or figuring out using the common difference. One last thing that we're going to do here is talk about the sum of an arithmetic sequence. So let's take a look at this example. I've got 60, 64, 68, 72, all the way up to 120. It's arithmetic because it's increasing by 4 each time. So there is a formula to find the sum of an arithmetic sequence or series, and that is this equation right here. So S base n, or sigma base n, just means the partial sum of a sequence. So this is only part of a sequence because it can go on forever if I keep adding 4, but we're just going to talk about these numbers. So n represents the number of terms that there are. A1 we know is our first term, an is our last term, and then we cut that in half. So what I actually need here is this n. I don't know how many terms there are. I could list them out, and it's doable for this example, but if I have something with, let's say, 1,000,000 terms, that would be exhausting. So we're actually going to use our handy-dandy nth term equation to help us figure this out. So I'm actually going to use 120 because this is the last term in this sequence here. So I'm going to plug in the numbers that I have. And 60 is going to be my first term there. And I don't know n, but I know my common difference to be 4. So let's figure this out. So when I work that all out, I get 16 for n, which means that there are 16 total terms here. So that means I can plug that in here and find the sum. So when I work everything out here, 16 goes in for n, the first term is 60, we add the last term and we divide it by 2. That all works out to be a sum of 1,440. And that's going to do it for this video. Thanks for watching.